Good afternoon, everyone, and we appreciate Fastmarkets giving us the opportunity to come and to be able to speak here at the conference, and we're glad we can do it in person and not have to just do it virtually, but those who are joining us virtually, we certainly welcome you as well. My name is Brent Wilson. I'm the CEO of Galvanic Energy. As far as the disclaimer here, it's a short one. We're a privately held company, so it won't have a lot of the typical things that you'll see in it, but and just mainly one of the things that we do is we interpret a lot of data that's available publicly and also through various subscriptions. And so we make no warranty on that particular information. Here's a picture, just myself and the rest of the management team that are here at the conference. Kind of make that available to you so you can recognize us. You can also recognize the rest of the team. James and Scott are sitting here in the audience, and Mark, I believe, is in the other session. But feel free to come by. We have a booth in the very back corner by where the coffee and refreshments are. So please come by and introduce yourselves. We'll be glad to meet you. So when I started to kind of put the slides together, I was immediately faced with a conundrum when I signed up. Now, sign up was pretty easy, but the challenge that I found is that you have a little pull down. And you know, when you get pull downs, you get only certain choices. And the choices were a little bit limited for us. We could either be Galvanic Energy, the oil and energy company, or our other choice is we could be known as a mining and metals company. Well, that was the conundrum, is we're kind of a mix. We're a crossover. We come from an oil and gas background, and we have numerous decades of experience in the oil and gas industry. But we have a very strong geoscience team. We're obviously very interested in the mining industry. We're interested especially in critical minerals, the metals, for example, with lithium. And so if I had a choice, and I created my own pull down, I would just simply say energy resource exploration. And you'll see that as being obvious as we go through the slides here, with a real heavy emphasis on exploration and early development of a particular project. So again, I come from an oil and gas background. Most of the team comes from an oil and gas background, so we're very familiar with exploration. But you know, when you come from oil and gas, obviously in today's world and the temperature of society, there's a lot of things that people think when they think about you being an oil man. And I'm not necessarily one that refers to myself as such, but if you're in the oil industry, it's what comes to people's mind. But if you look at an oil and gas well, such as are represented here by these particular pump jacks, the question that I typically ask individuals, and I'll ask you, is what do you think of? What's the first thing that comes to your mind when you see the jack, when you see the infrastructure, when you see the petroleum tanks? What are you thinking about? Well, to us, it represents data. And the reason it does so is because oil wells are unique in that they literally are windows into the earth. And whether it be just a few hundred feet or whether it be tens of thousands of feet, it gives us the ability to see things that are not observable from the surface. And even though in this particular case of logs, or electric logs as we refer to them, gives us a lot of great information, all of that information has to be interpreted, because what we're really looking at is we're looking at geology. We're looking at the rocks. And we're also looking at those things that are associated with the rocks. We're looking at, for instance, the reservoir system. And in some cases, we're looking at some of the chemical makeup of that particular reservoir. And so what we typically do and spend a lot of our time is interpretation. And so we're heavily involved in interpretation. We take that information and then we take it a step further. What we do is what we try to attempt to do is we try to recreate everything that we can interpret from that particular information. A lot of oil and gas exploration companies do that for obvious reasons, because we're looking for those hydrocarbon reservoirs, we're looking for the source rocks, we're looking for the trapping mechanisms, we're looking for a lot of those things. Well, the same can occur even for brine reservoirs, whether they be shallow or deep. Still, you have to understand certain mechanics of your geologic setting. And it's important to understand those things going in, because it helps you in your interpretation, but it also helps you, and especially in exploration, for instance, you're trying to advance your thinking into prediction. And prediction, obviously, is a very important element to the exploration phase. So we typically do geocellular modeling, where we try to compact information, and sometimes we'll even go so far as to synthesize literally the subsurface. We'll literally try to piece it back together, and we'll try to put it into not only into a visual aspect, such as in these 3D models, but we'll try to compact the information in such a way as to be able to extrapolate information from the data that's available. And of course, obviously data is very valuable, so a lot of data goes into these particular models, and sometimes the resolution can be all the way down to a half-foot interval. And so after we've done characterization, of course, in any exploration, you would then go out and you would delineate your potential prospect. You would identify the sweet spot. You identify where you ultimately want to go out and extract your potential minerals. And so I'll talk about this map here in just a moment, but just to kind of an insight into our Smackover prospect that I'll share more details of here in a moment. Our particular prospect that we ultimately delineated is a little over 100,000 acres. And so once we identified it, we set out a little over 2 years ago to be able to acquire the minerals. And so that's done through a particular leasing effort. In our case here in southern Arkansas, where the prospect is, it's very similar to oil and gas. Once you identify your area, you go out and you try to ultimately control the position, both of mineral and land, so that way you can actually be the operator and you can proceed with the development. In this particular area, it is a historic oil and gas field, and because it's in a historic oil and gas field, typically the mineral ownership is very broken. It's very challenging. We have in our area, our AOI, about 3,500 unique mineral owners. And in some cases, you know, when you think about this idea, and we separate this out as being a fee ownership, since it's privately owned versus federal ownership, such as with BLM acreage and other national or federal permitted acreage positions, we have to go out and actually negotiate with every single one of these mineral owners. We have to actually establish contract with them all. And so it's a tedious process. And even after you have established an understanding geoscience, from a geoscience perspective of what you want to go out and actually potentially operate or develop, you have to consider, you have to first gain a land and mineral position. And if you don't do that, you'll never be able to take your project forward, or you'll have various intervening operators or competitors that are within your footprint. And so that becomes a challenge in and of itself. So exploration's pretty stealthy business. We obviously don't talk about what we do until after we've done it. And then, of course, even in some of these cases, and I have here just a picture of a map, and yes, this is the maps our landmen work off of, and James Bryan, who is here with me, heads up our land department, and they have to go back, and it's not all digitized. It's not all easily available online. First of all, it's mostly just found in paper documents from generation to generation as they gave away mineral ownership to their children and then their children. You have to go back through and you've got to understand that, piece that back together, and of course, attempt to get it leased. One thing that I will say, because we come from an oil and gas background, is we understood ESG before ESG was a catchphrase. We often refer to as just simply license to operate. And in the oil and gas industry, whether it be what you produce or how you ultimately develop your potential project, to even, you know, what your representation is in the public, you know, all of these things obviously create all kinds of challenges, whether it be an environmental problem, whether it be that social issue within your community, or even regulatory challenges from the governance side. All of those things we're familiar with. And so obviously when we look to the lithium world, it's not uncommon, right? This industry deals with some challenges itself. Some of them are just perception issues. Some of them are real issues. But in any case, the challenges are real. They're in fact disturbing, because obviously the attempt of the industry is to try to help the country, to help the citizens attain certain lofty goals, such as reduction of CO2 emissions. And so, of course, electrification helps to reach that. But society, governance, environmentalists put certain rules, restrictions, and standards in place that we have to live up to so that we can operate. So with that in mind, we set out to develop a prospect that thought about ESG issues. And because a lot of ESG issues are just simply visual, such as in this particular comparison, from left to right, these are all exactly the same scale. These are 4 miles vertically in the picture that you see, 3 miles laterally, and you see the Atacama evaporative ponds on the left. You can see green bushes in the center. And then on the right, what's represented there is actually, that's where Standard Lithium is doing its pilot plant at the Lanxess South plant in Union County, Arkansas. And if you've been to their website, if you've seen their presentations, you obviously see that they have a certain scale steel building that's amidst a large plant facility. And what that plant facility ultimately does is it extracts bromine and creates brominated chemicals. And so they're one building out of many there, but obviously a lot of that infrastructure would be required even if lithium was the only thing that they produced. But in any case, you can see how much smaller the footprint is even from a visual perspective. And what's also there, and it's hard to see, and unless the trained eye can point those things out or can delineate those things, there's actually an entire well field surrounding that particular plant. And so they're usually spaced out, typically no more than about 20 wells. So with that, I'd like to talk about our prospect, and it is nearby this particular area. It's in southeastern Arkansas. It is in just one county adjacent. We'll show you the picture, but the nice thing about this location that we like is number one, it's a good temperature zone. It's not too cold. It's not too hot. It's not overly populated. There's a lot of things that ultimately drove us to look at this particular area. But the one thing that has developed on its own is just really the location of the mega factories. We didn't pick the locations, but the locations obviously are in an area that's optimal for the Smackover, and of course we have port access to this area as well. So here's a close-up, and it's modeling after a map that you're probably very familiar with that originally that Standard Lithium had published, just showing the different brine units or brine areas. We have this also available out on our table as a picture and also on our website. But you can see the galvanic acreage. It's in the green in the lower left. Directly to the north in blue, that's Tetra. Tetra actually does not have an active operation there, but they do have a joint venture with Standard Lithium. We have, obviously, to the far right, that's where the pilot plant is located, just for proximity to where we're located. That's where Standard Lithium is actively running their extraction testing. And then Albemarle also is there in red and adjacent to us. In fact, they have 2 plants. Lanxess has 3 plants. And one thing that's interesting here is bromine has been developed in this area for over 65 years. And even though bromine is not necessarily a target, we have it in high concentration here. But what I would point out is that the entirety of the area was built on the precedent that bromine had been identified and was economic back in the late 1950s. And so the original units here were established for purpose of extracting and developing bromine. It wasn't developed for lithium, but thankfully there was some data collected over the years that actually captured lithium values. And what we found interesting, even though we had looked from a geoscience standpoint at a number of other basins that had oil and gas production associated with them with plentiful data, is that in this particular area, no one had really delineated and modeled the lithium in this particular part of the basin. And so when we did, what we found is that the lithium was concentrated just in a juxtaposition to the bromine trend, just slightly to the southwest. And that's why we chose the location that we did, and then we ultimately delineated that particular area as our operation or our prospect. So just one thing to note is that we try to track, obviously, and just learned just a few minutes ago about even some values from the Salt Lake is that there's a number of brine prospects that are being promoted, and they're obviously coming out. And one thing that we did from the very beginning is we went looking for the highest concentrations of lithium. Of course, if you have high concentrations of lithium, you don't have to have as large a prospect to be able to achieve certain metrics that you're aiming for. But of the prospects that we know of to date, we believe we have the highest concentrated brine prospect. It's an average of about 325 parts per million. It's as high as about 460 parts per million. We do currently have additional testing that will be upcoming in the next couple of months, and that'll help us to further delineate if there is a higher number within our area. The thing about concentration, though, that's important to note is that in the end, concentration, I believe, is something that needs to be greatly considered in any kind of DLE approach. Now, of course, we like DLE. It's what we're obviously aiming for because we like the ESG message that goes along with it. But we also understand that DLE can be rather expensive. And depending on what type of DLE you have and what goes into that particular process, obviously cost considerations are very important. And so one thing that we need to realize is that there is an importance when it comes to concentration. It's why we focus on some of the highest concentrations that we can find from our exploration. If, for instance, in this particular case, in the graph on the right, the smaller graph, what that is showing you is what Albemarle reports to the state of Arkansas every year as far as how much fluid that they actually pass through their two plants. Remember, there's two plants associated with Albemarle. About 125 million barrels of brine is processed annually on average. Now, LANXESS, through three plants, does about the same. So a total of 250 million barrels pass through these plants annually in this part of the state of Arkansas. And so it's a very prolific reservoir. But when you think about the concentration, I want you to think about this. If I use 125,000 or 125 million barrels, which is on the y-axis of the graph that's a little larger and in center, then again, being two plants, and I have 350 parts per million or milligrams per liter, then what I ultimately would expect is the potential of a return of a little more than 40,000 ton lithium carbonate equivalent if I have about a 90% recovery rate. That's what this is ultimately emulating here. So that's good to know. But if I only have, for instance, 200 parts per million, then what I have to also realize then is, of course, I'm going to have a lower recovery. And in this case, I would have around 23,000 ton of lithium carbonate equivalent. And if I even threw in, for instance, an example at about 100 parts per million, then of course that falls even further. That would be about 12,000 ton lithium carbonate equivalent. Now I say that because I want to work this backwards, because a lot of companies that are promoting a DLE process typically and commonly try to use about 20,000 ton as their target, and that's a good target. But if you think about concentration and you're only starting at about 100 parts per million, then you're going to have to actually process over 200 million barrels of brine to ultimately achieve that. And of course, the more brine that you have to process, the more cost associated with your operation. It's going to be more energy, it's going to be more chemicals, it's going to be more of a lot of things. But if you start with something that has only 350 parts per million, then you're only going to have to actually pump around 50 million barrels. And what that comes out to be, at least here in the Smackover, is that's about the same amount as one full-scale bromine facility can actually process annually comfortably using about 20 to 24 wells, both injection as well as production wells. Whereas in the case of if you only have 100 parts per million, you could be building as many as 4 plants to process that. So just a couple of things as far as project appeal for our prospects. Some things to think about is, number one, because it's a fee-based mineral ownership, there's no federal permitting required, so there's not a lot of red tape associated with it. You just work with the local oil and gas commission. It's a low environmental footprint. Social and governance support has been promoted. Obviously, Standard Lithium has done a lot to help educate and share information about that. We've seen that ourselves. It's a domestic supply, therefore the transportation distance is low, therefore there's a low carbon footprint associated with that transportation. It's a low brine temperature too. We're about 100 C for our brine temperature coming from bottom hole, whereas geothermals are around 300 C or more. And then there's a negligible water loss because it's a closed system. And then, of course, finally, it's a high lithium concentration, one of the highest in North America. And that's it. I appreciate the time. And is there time for questions, or we take them later? And come find us at our booth. Of course, you've seen the team. Thank you so much.